Hi guys, welcome back to my channel. So in my previous videos, I've showed you how to install the QMK firmware, how to compile your own QMK keymap, and how to flash it using the QMK toolbox. Today, we're gonna explore the QMK firmware itself. So if you're planning to make your own QMK keymap from scratch for your own custom mechanical keyboards or your handwired mechanical keyboards, or if you want to learn more about the QMK firmware, then this video is for you. So what are we waiting for? Let's get tinkering.
So I've been using QMK firmware for a while now, and to be honest, using it for the first time gave me so many frustrating moments and sleepless nights. That's why I've decided to create a series of videos about the QMK firmware for those tinkerers like me. So let's start exploring the QMK firmware. First, let's go to the installation path. So MC64, home, the name of your desktop. So as you can see, I have different QMK firmware repositories by different authors, which proves that the community is very much alive. Now let's go to the QMK firmware. So let's focus with the keyboard folder and the layout folder. So keyboard and layout. So in the layout folder, you will see the different layouts of the keyboard. So if you want to build your keymap from scratch, then you will just go and check out this layout folders. So you could also base your hand-wired mechanical keyboards from these layouts. So let's go to the keyboard folder and check the DC60 mechanical keyboard. There. So let's open the Rules.mk. So here we have the microcontroller that we use in the keyboard. So the DC60 is using an Mega 32U4. Next we have the bootloader. You will need to choose in the selection what bootloader is compatible to your MCU. Then we have the build options for our keyboard. So we have the boot magic. So instead of using the reset button in the PCB, we just hold the spacebar and B and then plug the keyboard. Then we have the mouse key enable. This is to enable the mouse keys or mouse key codes in the QMK firmware. So we also have the extra keys enable. So if you want to use audio controls or system controls, then you have to enable this. We have the console and command enable. So this is used for debugging and configuration. Then we have the sleep LED enable. It says do not enable sleep LED enable because it uses the same timer as the backlight enable. Next we have the NKRO or NK rollover. Then we have the backlight enable for on-key LEDs. We have the RGB enable for RGB underglow or side glows. Then we have MIDI support. So this is the musical instrument digital interface So it is a standard protocol for communication between electronic musical instruments and computers. Then we have the Bluetooth enabled. So if you have a Bluetooth module that is compatible for the QMK firmware, then you should enable this. Then we have the audio enable. So if you want an audio output in your keyboard, then you should enable this. Then we have the Fox Clicky enable. So this one enables the use of buzzers to imitate the sound of clicky switches. Then we have the layouts of the keyboard. So these are the layouts of the DC60 mechanical keyboard. Next, let's go to DC60.h. So as you can see here are the different layouts of the keyboard. It also shows here how the switches are connected to each other. So example, in the standard arrangement layout, we have 5 rows and 15 columns. Here. So as you can see, each of this number or letter combinations all represents a switch. So this is a switch, this is a switch, and so on. So the digit on the left side is the row, while the digit on the right side, or the letter in this case, is the column. So that means that all these switches that has 0 on the left side is all connected to each other. Then all these switches that has 0 on the right side is connected on each other on the column part, so on the other pin of the switch. This one is one pin of the switch, and this one is another pin of the switch. Now let's go to DC60.c. So as you can see, these are quantum codes that is used for some features of the keyboards. Example, you want to control the LEDs of your keyboard. For example, the caps lock LED. Then this is the code that they are using. So you have the pin output B2. So the output pin B2 of the microcontroller is set as the caps lock LED. Right pin low B2. So it means that the LED is closed or turned off. So if else, then right pin high B2. So it means that the LED is open. So this is using the C language. So I'm not sure what rendition of C language, maybe Objective-C or C#. I'm not sure because programming is not my specialization. Then let's go to the config.h. So in the config.h, this is where the configurations of your keyboard is written. So we have the vendor ID, the product ID, the device version, manufacturer, product, description, and we have the matrix. So we have the 5 rows and the 15 columns. So you have to define it here. Then we will also assign the pins of the matrix rows and columns in the config.h. So in here, as you can see, DO is row 0, D1 is row 1, D2 is row 3, D3 is row 4, and D5 is row 5. So this pins is DO, D1, D2, D3, and D5 are the pins in your microcontroller. Then we have the matrix column pins. So here in the matrix column pins, we have the F0 as column 0, F1 as column 1, E6 as column 2, and so on. So in here, we will also define the direction of the diode. So as you can see, the direction of the diode is column to row. So for example, so we have this column, then we have a diode. So and then the row. Please pardon my representation because I've just used the notepad for it. So here is the column. Then this is the positive side of the diode or the input of the diode. So example, we have column pin, so FO. So F0, then we have a row D0. So the input side of the diode will be connected to the F0 pin of the microcontroller, while the output side of the diode will be connected to the D0 pin of the microcontroller. So that's it. So we also have the backlight. So the backlight pin that we will use is the B6, and we could also define the backlight level. So in here there are 5 backlight levels. So in here we define the RGB LED number. So this is the default configuration. We have 16 RGB LEDs. Then we define the U step. So we have 8 steps. So we have level 1, level 2, up to level 8. Then we have the RGB saturation step. So we have also 8 steps, and the RGB value step. So I think this is the speed of the RGB light. So we have also 8 steps. So in here we have the defined RGB light sleep. So I think this is the timer for the sleep of the RGB. So for example, if you're not using your keyboard for a long time, then the RGB light will shut off on its own. So we also have the define the bounds. So this reduces chatter or unintended double presses. So set to 0 if the bouncing is not needed. Then we have mechanical locking support. So for locking caps lock, locking num lock, and locking scroll lock. So we just enable it. Then we have the locking resynchronized hack. So I'm not sure about this. Maybe you could go read it in the QMK.fm website. Then we have the VIA related config. So since this is a VIA compatible keyboard, then we have to define it here. Okay, let's go to the Keymap folder. So as you can see, these are the keymaps that comes with the QMK firmware when you installed it. You have 60 ANSI, the default, HHKB, etc. So you also have poker and other layouts. So let's try the default here. So as you can see, it only have Keymap.c. So if you open it up, you could see the keymap. So you could edit this. You could just find the key codes in the docs.qmk.fm. You can also modify this to suit your own needs. You can define the names of your layers to make it less confusing. So let's define QWERTY layer. So let's say it's layer 0. So this means that your layer 0 is your QWERTY layer. Next, we define FN layer. So let's say it's layer 1. So this means that your layer 1 is your FN layer. We could also edit this. So underscore QWERTY was. So this means that this layout is your QWERTY layout or your layer 0. Next, now this means that this layout is your FN layout. Another one is if you have an SSD1306 OLED display module and you want to put it on your keyboard, go to the Rules.mk and type oled underscore driver underscore enable is equals to yes. Now let's go back to the Keymap.c. So let's go to docs.qmk.fm and check out the sample code. So this is the sample code. So we copy it, then let's paste it in here. So since we only have 2 layers, then we have to remove this one. So it says oled underscore right underscore p layer. So it will show layer in your OLED display. Now we have a case in here. So if you are in the QWERTY layer, then it will write default. So we could change it. So you could change it QWERTY. So if you are in the QWERTY layer, it will show QWERTY. So if you are in the FN layer, it will show FN. So example, if you want another layer, so numpad layer, so case underscore num, then just define it in here. Num 2, so layer 2. So you could copy this and just paste it in here, then put a comma in here, then change this into num. So you could write in here. So this says tg underscore num. Then you have to go in here, copy this code, then write numpad. Then you could just edit this to look like a numpad. So in here, So if you have the num lock, caps lock, scroll lock, then this will be the status of your keyboard. So example, if you activate num lock, then num will appear in your OLED display. If you activate caps lock, then cap will appear in your OLED display. If you activate scroll lock, then SCR will appear in your OLED display. So for example, you want to make your own handwired mechanical keyboard using an Arduino Pro Micro. Let's close this first. So let's go to the keyboard layout editor. So keyboardlayouteditor.com. So I will put the link below the descriptions. Just delete this. So let's say we're gonna make a 40% keyboard or a 40 key ortholinear keyboard. So add 10 keys, add 10 keys. So we have now 4 rows and 10 columns. So go to row data, copy this, then open a new tab and go to kbfirmware.com. So let's reload it. Then just paste it in here. Then import. So there you have it. So this is the wiring of your handwired mechanical keyboard. So please take note that this is the top side of your keyboards. You could edit this wiring depending on how you soldered the keyboard. Before we edit the wirings of this one to fit the connection of your handwired mechanical keyboard, first take note that the red lines are rows and the blue lines are column. So for example, this switch, I want to move it to column 1. So just go in here, then change column into 1. So now it is connected to column 1. Now let's choose this switch. So I want to connect this to row 1, so in here. So if you could see, the red line should move, not the blue line. So go in here and change the row into 1. So as you can see, the red line is now connected to row 1. So let's change it back and move to the next step. Then we go to the pins. So as you can see, row 0, 1, 2, 3, then columns up to 9. So depending on what pin in the Pro Micro you will connect this, then you need to edit it that way. And then you could choose the controller on your keyboard. So in this firmware builder, you only have 3 microcontroller. So since you are using Pro Micro, then you should choose Atmega 32U4 and then go to Keymap. So you could edit this depending on your preference. So there, for example, we have finished editing, so you could go to the settings. So layout name, Pro Micro 40. If you want to put some RGB underglow, you just put the number of LEDs. So example 8 LEDs. Then you could edit it in the pins. So if you want to put RGB, then just put the pins of the Pro Micro that it will be used for the RGB, or for the backlight, caps lock, scroll lock, and num lock LEDs. So go to the settings. So if you save configuration, it will download the JSON file. Now we compile. So we could download the hex file, or we could download the zip file. You can download the hex file to flash it in your keyboard, or you could download the zip file to edit it using the Notepad++ and compile it using the QMK firmware. So that's it. You have made a custom firmware for your handwired 40% ortholinear mechanical keyboard. So next time I will teach you how to make your own firmware for your handwired mechanical keyboard from scratch using other microcontroller. I hope you learned something from this video, and please comment below if you want to know more about QMK firmware, and please subscribe. Thank you and have a great day.